time to watch afterwards. Yeah, if it's a problem for you, maybe you don't want to do it right now.
No, that's okay.
Okay.
So this is going to be a continuation of the presentation about Gephi and network analysis. I'm going to share my screen right away. Let me just start here. So now I hope that I'm not quite sure what I am sharing. Is it a start of a presentation with small windows?
With small windows. The first one is with the title Network Analysis with corpus extraction.
Yes. So this looks good. Only, and now it's become bigger.
Yes.
Okay, so it looks as if it were working as it is supposed, and now it is moving. I can see it. Okay, so this is going to be a continuation of the last lecture where we looked into the basic network analysis concepts. And we had a use case of the migrant stories corpus metadata, of which we built a network to see from where from and where to the migrants were streaming, mostly. Just to rewind very quickly, a network consists of requires a table of nodes and a table of edges. It contains nodes, and the nodes are connected by edges. Both can have their internal structure with attributes and their values. The edges can be directed or undirected, or there are graphs that have both types of edges in themselves and are mixed. There are plenty of metrics that can tell you about each node, how important it is, while there are obviously different aspects of the importance. So it is either the number of edges that go out of the node or into the node, or no matter which direction, then it takes into account the inner structure of the edges, its the weights, or the neighbors of those neighboring nodes, whether they are well connected or not well connected in their own right, and that just makes features of individual nodes. We can also compute something about the whole network, or compute clusters of nodes that are connected by similar behavior. Today we are going to take up again the migrant stories metadata. But we are going to add to that table one more column, and that is something that I have extracted directly from the text. It's mentions of organizations. So which organizations we can ask with this knowledge, which organizations play a role for which sort of migrants, how, and of course, how to extract such information from the raw corpus in the first place. So partly we will stick to the network analysis today, and partly we will look back at the corpus query processor and demonstrate how we can extract annotated data from that. So this would be our raw data. It is a table that's in this software. It is tilted counterclockwise. So it says that it has 1,410 columns and rows and 13 columns. And then these rows that start with a $sign, these are actually the columns starting with the leftmost column at the top and proceeding to the right, to the bottom. And these are column headers. Then it says how many, which sort of data there is in each column. It says character here, and then there's a sneak peek into the data. So a few values that fit the screen from each of the from each of the columns. We have here, like last time, the text ID, which is actually the name of the file stripped of the folder path and the suffix. Then there's the new column, which I called org, like organization, and these are different organizations that have been extracted from the corpus. We also know that these names are very long for a network graph. That would be too cluttered, so we need something shorter, a mnemonic for that. So I added a column with abbreviations. These are admittedly not the most intelligible mnemonics in the world, but this is what the program spat out. So I'll stick to this. Then we have for each of the mention, we can add the country of origin of the speaker, and of course the continent on which it is located, and the same with the country of destination and the continent of destination. And also we had the column GDP change with the 3 levels: high, equal, and low. That could be handy too. Then we could have gender and again, names of countries deserve to be abbreviated so that they fit into the graph. And then the nodes table requires, in Gephi, requires a column that's called label and ID, two such. So here we have the label, which is also going to serve, could serve as an ID. And then I added, just for future reference, future extension of the research, a logical column that says whether this organization is a school or not. I did it just by means of a regular expression, asking for strings like school, college, university. So I know already that I have missed faculty, and there would be much more such stuff, but that's the baseline. That's how it is now. These mentions of the organizations by one speaker are deduplicated. It doesn't matter that this speaker was talking about Mennonite Center of Canada all the time and mentioned it 20 times. We just want to know that he or she mentioned it. So it's only once there. Before we go over to Gephi, let's look at the distribution of the organizations in the corpus, or the combinations of organizations and speakers, just in tables and on simple graphs. So these are the most mentioned organizations, meaning being mentioned by most people. That's IOM, which is International Organization of Migrants. Then EU is European Union, UN are United Nations. There you see that we have NGO, which means non-governmental organization, just any. It was caught here. I don't know what this IM is actually, but it was also very, very much used. Then we have the United Nations High Commissioner for Refugees, university, which actually here is just any university. AVWR is Assisted Voluntary Return and Reintegration, and a European platform. And then we have ISIS, which is also an important factor of migration, and political science, which I can't decipher what that stands for. The named entity recognizer in the corpus can just have been wrong as well. When we look at the distribution, we see right away that the top first institution is an outlier with the mentions, that the difference between the first and the second rank is huge, and then it's not so steep anymore. I just wonder whether it starts to be flat. It's starting to be flat like this, and would be just continuously going the same direction, or whether all of these are outliers. So I have computed the another table that shows the times. The left column means the distinct counts of people that mentioned an organization, and the right column is the organizations that have this number of mentions. And there we can see that the absolute majority of organizations was mentioned only once. So actually all of those others are outliers. Again, we see a very steep fall in the distribution here from 870 to 53, and then we have those few that are so unique. When we visualize it in a plot, then it would possibly look like this. Again, only the distance between this bar and this bar would be much larger. Then the bar would be somewhere outside the beyond the slide, and the same would go for this column's distance from this column. And to fit them on one slide, I squared the numbers. But so you don't have to. You would have to. You would have to exponentiate it on square two to get the exact the actual numbers that are here. That means that we actually will have to do with quite just a few organizations that are for which the network presentation is relevant. Since when something is not connected, then it has no sense to display it in a network. Another possible visualization would be a word cloud, where we again can see for the first, on the one hand, we can see the most mentioned or most quoted organizations, and also we realize how differently they behave from the others. Here I also played with the is school column, the Boolean one. So the blue stuff is something connected to education. obviously, from this graph, it is visible that it is a frequent, quite a frequent aspect of migration or reason to migrate, or is associated with migration. Only these are very specific places, individually chosen places, while the migration organizations operate globally, so they are meant for they display with many more people. So I created the nodes table as we did last time, and this is a summary of the nodes. I created two types of nodes. One type is the humans, the speakers. We have 552 speakers, and we have 963 organizations. Then with the school, we see that we have 124 schools, 839 not schools, and these NAs are the people. Again, we see the distribution of dimensions. The maximum is 171. That's the IOM. Obviously, the people were not mentioned. So this is, again, this 552 here. And then we see that the mean and median are precisely one or very close to one. So we also here get the idea about the distribution of dimensions. The edges table looks like this. It always connects a human with an organization. It never connects directly to organizations or to humans. When we display a few people, how they look like. So this would be this would be the ID of their target of the target value. We start in Gephi like this. This ugly hairball is just a random graph that it starts with when we import the tables for nodes and edges, and I mapped the type of edge directly on node color. So I think the red edges are the people, and the green edges are the no, the other way around. The red edges are the organizations, and the green edges are the people. It is obviously a very cluttered graph, so we have to do something about its layout, and also filter out stuff that isn't connected so much. When we give it a more legible layout, then we can get something like this. I did this with the Irfan Hue algorithm with pretty much expansion. And here we see right away that this is something that we can filter out, because these are individually specific organizations mostly, and that the important things happen here around this. This is for sure the IOM, and there would be several more interesting islands. That's actually speaking about islets or islands. There's a concept in the social network analysis that is called giant component, and it is a magical thing that is mathematically very very complicated, but Gephi has algorithms to compute it, and it is roughly speaking, a maximally connected subgraph that you can find in the whole graph. So what you can, if you dig into the soil of the graph, so what sort of what coagulates most, what you will have as one entity, or something loose but still loosely hanging, loosely coherent, that would be the giant component. And this is showing that the most important organizations are actually interconnected, because when you grab the component, it contains all those big ones. But it is, again, it's not legible at all. So we would have to get rid of the organizations that just hang on those people, like people who use the IOM probably also used or mentioned some of those. That's why this outer circle is here. But it clutters the graph, and we would like to get rid of it. Which brings me to filters again. So when we filter out those organizations that are most important, and the people that are directly connected or closely connected with these organizations, we will get a much better legible graph where we can see the individuals and display different attributes of the human nodes, and then manually just make inferences of it. So I have displayed their country of origin here. So obviously we don't know whether this Syrian Arabic Republic is the same one as here. One's connected to IOM and one's connected to NGO, or whether it's the same one talking about. Well, yeah, or whether it's the same one talking. Well, no, we could say that anyway. So these would be different individuals. It is pretty well visible that maybe I've already picked it here. Some parts of the island. When we map other attribute values of the nodes on it, we can also see the GDP per capita change here. I think that this teal one or this blue one is from high to low. This one would be, I think Gambia would be in Syrian Republic. This would be equal, and this would be high. The green ones would be high. And these are their destination countries. So people from these countries, which are very often poor countries like Afghanistan and Syria, Ukraine, Peru, Martinique, they when they go to universities, to countries where they encounter a big change in wealth upwards, then of course there's much academic mobility within Europe and the United States and United Kingdom as well, and some people from rich or relatively rich countries, they are not afraid of lowering their material standards when they go to universities. On the other hand, here we have another island that's the ISIS, and there you see that it very much makes sense how it is with which countries or people from which countries mention ISIS. It's of course it's Syrians, Sierra Leone, Eritrea, Afghanistan, Syria again. And these are close to those global migrant organizations. This is UN Migration Agency. So you see again that this is this is probably people who are fleeing from countries with conflicts or very low material standard. So how should we create such filters again? At first it's practical to just create the giant component and get rid of everything that doesn't belong to it, and then we have to say I want just organizations, so nodes of category organization that has high in degree. That means which is mentioned by many people. Organizations in my graph, I organized the graph so that organizations don't have out degrees; they only have in degrees. And so this would be, I want just the big organizations so that I don't get the outer ring or outer circle of the less important organizations and in between sandwiched the people that mention both the big ones and the more specific ones. Then to get the people in as well, then I also have to mention the people category. And either I would pretend to make a restriction, but the Gephi is fine even just mentioning a category that it should be there without imposing any artificial restrictions there. It looks like this. So these are up there somewhere is the catalog of the values and attributes and their values. And here we can build the query. So it's actually two steps. One is the giant component. And on this filter, I apply the simultaneously valid conditions, restrictions on the humans and the organizations. So this would be, these two don't matter. I think they shouldn't matter which comes first and which comes second. So here it is a categorical variable, the category, right? It has just two values, a human or organization. So it's partition. I take the partition from the catalog and I'm looking for the parameters. It's the category columns and the parts are the values that are offered to me. So I want to restrict the category to organizations, and in these organizations, their in degree range should be at least 6 and up to the maximum. So that would be the organizations in the union. The first member of the union is this. The second member of the union is the humans. So again, it is partition category. You see, it's here and here because I want I want 2 different values of the same attribute. So this is the second one, and I only say that the category has to be human, and I have no subfilters here. And this made me this powerful filter there. Like the previous time, it's becoming obvious that the speakers per se are not very interesting. We don't know much of them as individuals. It's actually, they just represent different paths or combinations of countries of the origin and the destination country. So how about if we try to declutter the graph again with not focusing on individual speakers, but making a frequency table of where each row would contain the mention of an organization, the name of an organization, then the path with which it was mentioned, so that it was mentioned by people on that path from the origin country to the destination country, and then in another column, how many these people were. So how many times it happened that someone going from New Zealand to Cambodia mentioned IOM, for instance. Again, well, nodes are countries, so this time we only have one category of nodes, one type of nodes, and the organizations can be hidden in the edge labels, and also the GDP change can be hidden in the or stored in the edge labels. We can play around. I think that this is just design decisions that then pretty much shape the questions we are able to ask. So it's important to make these decisions consciously before one starts drawing the graph, or just know that there were several options and that is one of them. So the nodes, they are connected. They are connected like paths. They are connected through the trip. So it's always the country of destination is targeted by the country of origin. The edges are the path. Then edge weights are the path counts. So how many times it happened. First, I thought I would keep gender there as well, but it turned out obviously it's clumsy because when you decide to not to use the gender, then you have then you have the nodes duplicated, and then you have duplicate nodes, and that's a nuisance as well. So I would just drop this gendered path, and non-gendered path means the frequency with which this trip with this organization occurred. Then in the edge label, we have the name of the organization, and yet another label, we have the GDP change. This would be the starting point. And indeed, although it's again ugly and cluttered, it's by far not as horrible as the one with the individuals was. So hopefully it's going to be more comfortable to work with. And again, I applied filters. Now we know which organizations are the important ones. So I was asking about the edges and their weights as well. And this was the partition filter. In the partition, Gephi displays also the edge attributes when they are categorical, and organization name is a categorical variable. So I put it there, and I was asking about a concrete organization. Most filters, if you ever do this by yourselves, you need to know that these filters can't access the label column, that column that is called label and that is required. So you have to go into the data lab, and there are buttons which allow you to slightly tweak the tables you have there, and you can for instance duplicate columns and rename the duplicate. So this is what I did here to be able to filter on the edge. And this would be another partial filter, which shows the migration for culture and education. So I picked the edges with orchestra, university, TEDx, this sort of stuff. And indeed, you see that, well, that actually even that even people from war-torn countries mention these organizations. It would be but sometimes it's genuinely interesting. Look here, the United Kingdom is connected to Iran by TEDx 12 times. So I would really wonder how it's possible. Well, it's really a nice coincidence that 12 Iranians went to the United Kingdom to a TEDx event. And now let's switch to the extraction of organization mentions from the corpus. To search the corpus, you can go to this website. It's the TATOC installation of the migrant stories corpus. And to use the advanced search, you have to log in with your personal login, not with your institutional SSO login, and then you will get into this menu. So normally you would see this corpus search. You would be able to open a query builder here, and it would all happen here. But then there's something for admins or super users, and that's this unassuming link on the very bottom of the page. So when you go over there, you will get such a raw query window where you can type a sequence of SQL queries, not much different than the ones in the ordinary one. But what is so important about this interface is that you can export, that you can make custom exports of the data. you will be able to export a new CSV file with your findings, with the matches you get, along with the metadata columns, which is incredibly precious when you want to feed it to a network graph or anything that like. Just imagine text like in 2005, I arrived in Auckland, New Zealand. The text has been automatically annotated with named entities. So it knows that Auckland is one named entity and New Zealand is another named entity. And even it guessed correctly that it is location. There are, I think, three types of named entities there. That's location, person, and organization. It would be very easy, very user-friendly if one could just ask about the location named entity attribute and its value inside one token, as you did with Jirka in the information extraction task. But unfortunately, the named entities are made differently because they are typically multi-word expressions. And the annotation scheme, the XML scheme of the corpus has to display this or treat this adequately. Let's look at the two instances of named entities. One is the one word Auckland, and the other one is the multi-word expression New Zealand. So that here is the token Auckland. The token starts with the tag tok, like token, and it ends here, and tok. It has several attributes in there. The ID of the word in the corpus, then its rank in the word order of the given sentence, then the lemma, then the part of speech and the traditional part of speech, the linguistic features, then it has a reference to the node that by which it is syntactically governed. That's the same, that's the word order of that head, and that's their syntactic relation. And here is the form of the word, that what you actually see in the corpus. So all of those you would be able to ask within or call within the square brackets, as Jirka showed you, not with name. Name is outside the it surrounds, is an element that surrounds the token element or token elements, and has to be approached differently, and I will show you how. To make it even more obvious, let's look at one that is a multi-word expression. Here, the New Zealand. Here you see new, and here is Zealand. This is the token of new. Here it starts with all the attributes and their values it has. And this is the end tag. So here we have the word new. The other token, Zealand, is the same story. A token starts here. This is its ID, the word order, the lemma, and all the linguistic features. Here is the actually observed form of it. Here, the token ends. And both of them are inside this name element, which in its right has attributes, and the most interesting one for us is type. So both are of type block. And here they also say how far they span. So how to ask about name? When we, and for which task? The export, the task would be just to export a CSV file with the entire named entity and some metadata. So let's say a text ID is enough. So this is what we want to achieve with a corpus query. So one part of it is to find out how to ask for a whole named entity, no matter how many tokens it takes. And the second part of the task is to create such a table to download. In the raw query interface, you need to use 3 lines. First of all, your query will contain a wildcard saying, I don't know how many words it has, so 1 and more words like this, and the regular expressions with which this corpus query processor works, they use regular expressions. So they work in different modes. Either when you don't say them exactly how long of the match you want to have. If you say 1 or more such token and a chain of them matches, so either they pick just the shortest one, or they pick the longest one, or then there's some third option as well. And because you want the entire named entity, you have to make sure that you go for the longest one. So this would be the first line, set matching strategy longest. That's just a cookbook. Don't change anything there. Then the query itself. So if you were in the regular search GUI, you would start here. So here is any word or any token, 1 or more. This is said with this plus here. And now, in addition, also would be possible to do in the normal GUI. It says this stuff has to be, this deliberate token has to be enclosed in an element that is called name. This is the start tag, and this is the end tag. And we want this to be further specified with respect to these nodes, the one node or several nodes that we get there. So we have to name this node. So I call it my node. This is something you invent. This is the name of the node you invent, colon, and where you use it. Then after the query, you set a double colon, and then something about the node that you are searching here, about its inner structure, internal value, internal attribute value structure. Here you again refer to the node by its name that you've invented for it here, dot, and from what you want from that node, what attribute it has, and on the page with the simple GUI, you have all those attributes listed, and one of them is name type. So I want the name type of this node to be org. So here it is. If you try out this query in the graphical user interface, you will get them nicely there, but you won't be able to download them, or you will be able to download the sentences where they occurred, but they won't be enclosed in brackets. You won't, for further processing, you won't be sure where the match starts and where it ends. So here, therefore, you have to use this one. And here, what is specific about this is that you have to name your query or store your query in a variable. So I called my variable my query, and I assigned to this my query this entire query. Each line has to end with a semicolon, which so here is actually an error. Here also should have been a semicolon. And so this is the query. You ensure that you catch all positions, and now the third line will design the export table for you. You use the verb or function tabulate, and it needs to have a variable. So that would be the my query. Now I can see I have another error here. I'm not consistent here. So either imagine my queue here or my query here. These two should be the same. And now you have to tell Corpus Query Processor what you want from the my query. It can give you the entire sentence, or how much context you want from the actual match. The match is defined by two positions, by its starting position and by its end position. The start position is called just match, and if you want some context before, you can replace this 0 in the square brackets with a negative number. If I write match -5 here, then it's going to export for you 5 words before the name of the organization. If you don't do it, you still have to put a 0 here. And that means just give me the match from its first position. You can as well start with the second or third position if you have long matches. But here we start just at the beginning. And when you want this all the way to the end, then you use these 2 dots and name the end, which is called match end. So again, this is sort of an idiom saying I just want the entire match here. If you write just here, you will get a bunch of numbers for each match. That's going to be their internal IDs. That is obviously not what you want. You want the words either in their forms or in their lemmas, or you want the part of speech tags or something. So here you just write what attribute you want to display from this. So if you need the form, then just write form. If you want the lemma as well as the form, then you just repeat this entire thing, like match 0 to match end form, match 0 to match end lemma, etc., and separate them with commas. These commas are separators of columns in your future table. So this would be the first column. This would be the second column. When you refer to something that that is metadata, that is not part of the text, of the corpus text, then you refer to the position as match. So, and then you name the attribute here, text ID. Each token knows from which text it comes. So it has this text ID column as well. So it's not like match 0, match and text ID. These are, again, idioms. You have to write it differently. And that would be it. There you get it. You can extract immensely much from it. So let's just imagine that you want to know how people judge about things. Like the linguistic proxy for that would be which adjectives and which adverbs they use, how they describe the things they encounter. So again, there would be, let's say we have set the matching strategy to longest or whatever. Here it doesn't matter really. So you would as well be able to do without that line. So you define your variable, here my q, and here you formulate your query. That's it, and that one is very simple. Give me one node, one token, whose part of speech is either adjective or adverb. This is something you would be already able to formulate, probably. Then semicolon, and on a new line, I failed to make a new line here, you again call the tabulate function on your query variable, and then you extract all those columns. So again, this time you extract lemma, not form, from the entire from the entire position. I think that here it would be enough to write match 0 and not you would not need match end because it is when it's just one word it should work as well. Never mind, it doesn't hurt. So here you would have these adjectives and adverbs. You would again get the text ID of the match, the country of origin of the text, so of the speaker, the continent of origin, the country of destination, the continent of destination, the GDP change, then the GDP per capita, and all those things that are already encoded in the metadata in the corpus for you. This gives tremendous fun to do. Of course, it's not all of such queries would be suitable for displaying in network graphs. I was just looking for something that would, and I hope that this mentioning of organizations made sense partly. It has some learning curve, this corpus query language in this corpus query processor, but it is pretty well documented in the tutorial here, and I hope that you will find it useful and maybe try it out yourselves, and maybe that you will even present something for me about this in your final presentations. Okay, so that was all for today. And next time we have Barbara with introduction to machine learning. So are there any questions? You don't have to ask anything, Mahmoud. I'm okay with that. So let's call it a day today and see you next time. Bye-bye.